myself, Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss applications of partial derivatives. So let us begin with the first topic, that is local extreme values, or we can call it as maxima and minima. So there are few steps. So let us discuss the steps. So if u is equal to f of x comma y is a given function, then apply the following steps to find the extreme values, right? That is maxima and minima. So the step 1 is, firstly we have to find the values of p, q, r, s and t, where p is equal to fx, that is partial derivative with respect to x. Q is equal to fy, partial derivative with respect to y. R is equal to fxx, that is higher order partial derivative with respect to x. S is equal to f of x comma y, that is del square f upon del x del y. And lastly t is equal to fyy, that is del square f upon del y square, right? So step 2 is, then we have to find stationary points a comma b by taking p is equal to 0 and q is equal to 0. We have to take both p and q together and solve them and find the points a and b. Step 3, find the values of r, s and t at our stationary point a, b, and then find, this is the most important step, rt minus s square. Now in order to find the extreme values, we have to check the following conditions. If rt minus s square greater than 0, then there will be two parts. First is r greater than 0 and the next is r less than 0. Again I repeat, if rt minus s square greater than 0 and r greater than 0, then we will get minimum value at that particular point a comma b. Again, if rt minus s square greater than 0 and r less than 0, then we will get maximum value at a comma b. So we will get extreme values only when rt minus s square is greater than 0, right? Next, if suppose rt minus s square is less than 0, then that point is known as saddle point, right? That is, f attains both maxima and minima at a comma b. That is, if suppose if we take example of this type of graph, that is of x cube. So this function attains both maxima and minima at origin, right? So origin is known as saddle point. What it is known as? Saddle point, right? Next, if rt minus s square is equal to 0, then we cannot apply this method, that is we cannot get any solution about extreme values. So let us solve few examples. So the first example is, we have to find maxima and minima of x cube plus 3xy square minus 3x square minus 3y square plus 7. So let us begin with its solution. Step 1, that is p is equal to fx, that is partial derivative with respect to x. So we have to keep y as constant. So keep y as constant in this. So this will be constant, this will be constant. Now start doing the derivative. So the derivative of this will be 3x square, derivative of this will be 3y square, because derivative of x will be 1. Here the derivative will be 6x. These two are constant terms, so derivative will be equal to 0. Similarly, find q, that is equal to f of y, means partial derivative of f with respect to y. That is, we have to keep now x as constant. So this term will remain constant, this will remain constant, and this will remain constant. So derivative of this will be equal to 0, and these two are constant. Derivative of y square will be 2y. So finally we will get 6xy. derivative of this will be equal to 0 because it is constant, and derivative of this will be equal to 6y, and this is again constant, so derivative will be equal to 0. Now let us find r, that is equal to f(x)(x), means del square f upon del x square, that is equal to del by del x of del f by del x. Put the value of del f by del x, that is 3x square plus 3y square minus 6x. So again keep y constant. So what you will get your answer as derivative of this will be 6x. This is constant, so it will be equal to 0. Again derivative of this term will be minus 6. Now let us find fxy. So fxy is equal to del square f upon del x del y, right? So this is equal to del by del x of del f by del y. Your del f by del y is equal to 6xy minus 6y, right? So do the derivative of this term with respect to x, keeping y constant. So the derivative of this will be equal to 6y, right? Next let us find t, that is equal to fyy. So fyy will be equal to del square f upon del y square. So you have to do the derivative of this term, that is our q, with respect to y again. So the answer will be again 6x minus 6. Now let us go to our step 2, that is we have to take p is equal to 0 and q is equal to 0. That is 3x square plus 3y square minus 6x is equal to 0, and 6xy minus 6y is equal to 0. Now solve the two equations simultaneously. Firstly we will solve this, that is 6xy minus 6y is equal to 0. So on further simplification you will get 6y into x minus 1 is equal to 0. So finally y is equal to 0 and x is equal to 1. Now let us put these two values in this equation. So firstly we will take y is equal to 0. So put y is equal to 0. So you will get 3x square minus 6x is equal to 0. Take out 3x common. So you will get 3x into x minus 2 is equal to 0. Therefore x is equal to 0 and x is equal to 2. So our stationary points are 0, 0 and 2, 0. Right? Now let us go to our case 2. That is we will take x is equal to 1. So answer will be 3y square minus 3 is equal to 0. So finally the answer of y will be equal to plus or minus 1. So our points are 1, 1 and 1 minus 1. So totally we have got how many points? 4 stationary points. They are 0, 0, 1, 1, 1 minus 1 and 2, 0. Now let us put all these values in our r, s and t and then find rt minus s square. So firstly we will put the point 0, 0. Our r is 6x minus 6, s is 6y, t is 6x minus 6. So let us put 0, 0. So in place of x put 0 and in place of y put 0. So you will get answer minus 6. Here you will get answer 0. Here again you will get answer minus 6. Right? So your answer of RT minus S square will be equal to 36. Done? Next, let us put the value as 2, 0. That is in place of x you have to put 2 and in place of y you will put 0. So here it will become 12 minus 6 which is equal to 6. Next here again it will be equal to 0 because y is 0. Next here similarly we get 6. So totally RT minus S square will be equal to again 36. Next let us put 1 comma 1. So if you put x as 1 in this it will be 6 minus 6 which will be equal to 0. Next put 1 in this, so S will be equal to 6. Lastly this will be same, that is 0. Finally find RT minus S square. So it will be 0 minus 6 square. So we will get answer as minus 36. Similarly lastly put 1 minus 1. Put x as 1. So answer of r will be again 0. Answer of s will be minus 6. And similarly answer of t will be same as r, that is equal to 0. Again find rt minus s square. So 0 minus 6 whole square. So again you will get answer as minus 36. Now we will conclude this by finding maxima and minima. So firstly check where we are getting rt minus s square as greater than 0. So we get greater than 0 in these two. So now check the value of r. Here you can see that the value of r, that is minus 6, which is less than 0. So we will get maximum at 0, 0. Put this 0, 0 value in your question. So you will get answer as 7. So you got your maximum value as 7 at point 0, 0. Similarly here too you are getting rt minus s square as greater than 0. So check the value of r. Here also we have greater than 0. So both are greater than 0. So we will get minimum value at point 2, 0. Put this point 2, 0 in our question. So you will get your answer as 3, which is your minimum value. And here rt minus s square in the points 1, 1 and 1 minus 1 is both less than 0. So here we are getting saddle points, right? Let's see one more example, which is find the maxima and minima of x cube plus 3xy square minus 15x square minus 15y square plus 72x. So now let us begin the solution and start our step 1, that is find p is equal to fx, that is partial derivative of f with respect to x, keeping what constant? Y as constant. So the answer will be 3x square plus 3y square minus 30x plus 72. Now find q, that is equal to fy. So that will be equal to 6xy minus 30y. Here you have to keep what constant? X as constant. Now we have to find r, that is equal to fxx, that is partial derivative of f with respect to x 2 times, that is del square f upon del x square. So do the partial derivative of this term with respect to x again. So the derivative will be 6x. The derivative of this will be equal to 0, and from here you will get minus 30 because derivative of x will be equal to 1. This is constant, so derivative will be equal to 0. So your r is 6x minus 30. Next let us find s, that is equal to fxy. That means del square f upon del x del y. So you have to take the answer of q and do the derivative with respect to x partial, keeping what constant? Y constant. So answer will be 6y. Now lastly find the t, that is equal to fyy, that is del square f upon del y square, 2 times derivative with respect to y. So the derivative answer will be 6x minus 30. Now let's go to our step 2. That is, we have to take p is equal to 0 and q is equal to 0. So put the values of p and q. So 3x square plus 3y square minus 30x plus 72 is equal to 0 and 6xy minus 30y is equal to 0. Now let us solve this equation, that is 6xy minus 30y is equal to 0. Take out 6y common. So finally what will remain? X minus 5 is equal to 0. Therefore y is equal to 0 and x is equal to 5. Let us start our case 1. That is, firstly we will put y is equal to 0 in our this equation. So put y is equal to 0. So what you will get? 3x square, this will become 0. Minus 30x plus 72 is equal to 0. Take out 3 common. So you will get 3 times x square minus 10x plus 24 is equal to 0. Simplify this, that is you have to do factorization. So factors will be x minus 6, x minus 4 is equal to 0. So final values of x will be 4 and 6. So therefore 4, 0 and 6, 0 are our stationary points. Now let us go to our case 2. That is, we will put x is equal to 5. So what we will get? 3y square minus 3 is equal to 0. Now take out 3 common. So 3 times y square minus 1 is equal to 0. So finally the value of y will be equal to plus or minus 1. Therefore our stationary points are 5, 1 and 5 minus 1. Therefore, in all, total we have 4 stationary points, 4, 0, 6, 0, 5, 1 and 5 minus 1. So now let us go to our step 3, that is, we will put these values in our r, s and t and find rt minus s square, and then we will conclude by finding maxima and minima. Firstly, let us put the point 4, 0. And our r is 6x minus 30, s is 6y, t is 6x minus 30 again. So let us put 4, 0. So on putting x is equal to 4, what we will get? 24 minus 30, that will be equal to minus 6. Same, put y is equal to 0 in s, so answer will be 0. Again this is similar as r, so again answer will be minus 6. Now let us put 6, 0. So on putting x as 6, you will get 36 minus 30. So answer will be 6. If you put 0, s will be again 0. Now if you put again x as 6 in t, so answer will be 6. Now in these two, let us find rt minus s square. So it will be 36 and in these two it will be 36. Now let us find at point 5, 1. So on putting x is equal to 5 over here, you will get 30 minus 30, that is equal to 0. Now if you put y as 1 in this, you will get s as 6 and similarly t will be equal to 0 because it is same as r. Now find rt minus s square. So it will be 0 minus 6 whole square. So answer will be minus 36. Lastly, put the point 5 minus 1. So on putting 5, you will get 30 minus 30. So it will be equal to 0. And if you put minus 1 in place of y, so you will get minus 6. And in last, you will get answer as 0. So rt minus s square will be equal to 0 minus 6 whole square. Again you will get minus 36. Now let us see our rt minus s square. In these two we are getting greater than 0. So we will get extreme values at these 2 points, that is 4, 0 and 6, 0. So firstly let us check the value of r. Here it is less than 0. So we will get our maximum value at the point 4, 0. By putting the value 4, 0 in our question, you will get answer as 1, 1, 2. And lastly, put the point 6, 0. So on putting the point 6, 0 in our question, you will get minimum value at the point 6, 0 as 108 because our r is greater than 0, right? And in last 2 points, rt minus s square is less than 0, so we get saddle points. So in today's lecture, we have discussed the most important method to find maxima and minima, right? So there are few steps. That is, first we have to find p, q, r, s and t, where our p is fx, q is fy, r is fxx, s is fxy, t is fyy. This is our step 1. In the second step, we have to take p is equal to 0 and q is equal to 0. We have to solve this simultaneously and find our stationary points AB, right? You have to find your stationary points. Then put the values of the stationary points in our step 4 and find rt minus s square. Now there are 3 cases. If rt minus s square greater than 0, then we will get maxima and minima. When we will get maxima? When r will be less than 0 and minima when r is greater than 0. Now we will get saddle points, right? So we don't need to find anything further. And if rt minus s square is equal to 0, then we cannot find any conclusion, right? So I hope you understood the method. Thank you for watching.